Hello everyone. In this video we are going to deal with mainly about the collisions. So first of all, what is meant by the collision? A collision is said to be occur in two bodies either if they physically collide against each other or if the path of one is affected by force exerted by the other. That means collision can occur when they are colliding each other, or maybe the two bodies are in contact when they collide. It is not necessary to make the contact. You can see in the second point here, if the path of one is affected by the force exerted by the other. So it is not necessary in physical contact. So without physical contact also we can say that the collision is taking place when the path of one is affected by the force exerted by the other. Now there are different types of collisions we have to discuss. The first one is called elastic collision. So what is meant by elastic collision? The examples for elastic collisions are the subatomic particle, there are collisions are there, right? So subatomic particles when they are colliding, that type of collisions are called elastic collisions. So how you can identify the elastic collision? You see some characteristics of elastic collisions. Here in elastic collision, momentum is conserved. As you already learned that one, momentum is conserved. Total energy is also conserved and kinetic energy is conserved. And moreover, in all the elastic collision, forces involved during the collisions are called what? Conservative forces. Which forces? Conservative forces. And the next point is that the mechanical energy is not converted into heat, light, sound, etc. That means no energy is wasted in the form of heat, light, sound, etc. The other type of collision is called what? Inelastic collision. What is that? Inelastic collisions. What is meant by inelastic collisions? Inelastic collision means momentum is conserved. Okay, always the momentum is conserved in any type of collision. Next one is total energy is conserved. But you see this one, kinetic energy is not conserved. So what happened there? If there is a loss of kinetic energy during the collision, and that type of collision is called what? Inelastic collision. Now look at the fourth point here. Some or all the forces involved during the collisions are called what? Non-conservative. What is that? Non-conservative. And the mechanical energy is here converted into heat, light, sound, etc. So some energy is dissipated in the form of what? Heat, light, sound, etc. So this is called what? Inelastic collisions. Now the next type of collision is called what? Perfectly inelastic collision. What is meant by perfectly inelastic collisions? You can see that when two colliding bodies stick together and move as a single body with a common velocity after the collision. So what is meant by perfectly inelastic collision? When the two bodies stick together after the collision and move as a single body and with a common velocity, and that is called what? Perfectly inelastic collision. So let's discuss about what is meant by perfectly inelastic collision. Just imagine one body here, say it as the body is having the velocity u1, moving with the velocity u1. The mass is here, we can note it down as m1. Another body, say it as the mass is m2. Okay, and just we are imagining that this is now at rest. What will happen after some time? M1 is coming with a velocity u1 and M2 is at rest. Definitely after some time what will happen? The bodies will now collide. Now you just imagine, okay, just imagine after the collision M1 and M2 are stick together. Okay, M1 and M2 are stick together. Now it is moving with a common velocity, say it as V, a common velocity V. Now you can see here this is stick together and moving with a common velocity, right? So this type of collision is called what? Perfectly inelastic collision. So what is the momentum conservation? Let's discuss about the momentum conservation here. So linear momentum is conserved in this collision, right? So what is the momentum before? Momentum before is equal to m1 u1 plus, what is the momentum of the second body? 0, right? which is equal to momentum after collision. Momentum after collision means what? m1 plus m2 into velocity v. So in this case, what is the common velocity? We can write here the common velocity of these two bodies together. V is equal to m1 u1 divided by m1 plus m2. So it has equation number 1. So this is equation for what? Common velocity when the bodies are in perfectly inelastic collisions. Okay. Now what is the loss in kinetic energy on collision? What is the loss of kinetic energy? Let's discuss about loss of kinetic energy in this case. Loss of kinetic energy in this case. So the loss of kinetic energy, we can say it as the delta K, change in kinetic energy. The loss of kinetic energy delta K is equal to initial kinetic energy minus final kinetic energy. So if the energy is losing, definitely initial kinetic energy will be more than final kinetic energy, right? So that energy, the loss of kinetic energy may converted into what? Heat, light, sound, etc. Okay, so let's use that formula here. Delta K is equal to, now what is the initial kinetic energy? Initial kinetic energy is only for the first mass, so half into m1 into u1 square minus what is the final kinetic energy? Final kinetic energy is equal to half into m1 plus m2, that is the total mass, right? m1 plus m2 into v square. Now we have already calculated here what is V, right? So we can substitute here the change in kinetic energy or the loss of kinetic energy is equal to half m1 u1 square minus half into m1 plus m2, okay, m1 plus m2 into v square. What is V? See the equation number 1, that is m1 u1 divided by m1 plus m2 the whole square. So if you calculate this equation, m1 plus m2 will cancel. If you calculate this equation, m1 plus m2 and 1 m1 plus m2 will cancel. This is squaring, right? So we can write this equation as delta k is equal to half into m1 into u1 square minus, you see this one in the numerator it become what? m1 square u1 square, squaring it is, right? m1 square u1 square divided by 2 into 1 m1 plus m2 plus m2 cancels, so remaining one, once again 1 m1 plus m2 is the correct. So this is the relation for loss of kinetic energy. Okay, once again if you take the common thing outside, you can say here delta k is equal to, you see half into m1 u1 square is common. If you take it as a common, you can write it as 1 minus m1 divided by m1 plus m2. m1 divided by m1 plus m2. Now inside the bracket you cross multiply and get the final answer as what? Delta k is equal to half into m1 m2 divided by m1 plus m2 into u1 square. So this is the loss of kinetic energy. Loss of kinetic energy. You can see here this is a positive quantity. So definitely the kinetic energy is lost mainly in the form of what? Heat and sound. The next one is that super elastic or explosive collision. What is meant by super elastic or explosive collision? So during this collision, if an increase in kinetic energy is there is an increase in kinetic energy, then that type of collision is called what? Super elastic collision. For example, a bursting of a cracker. Okay, bursting of cracker means what? It is due to the release of potential energy inside it, right? It is due to the release of potential energy. So what will happen? The kinetic energy may increase during it explode. During it explode. The next type is called what? Head-on or one-dimensional collision. What is that? One-dimensional collision. What is that meaning? Colliding bodies moves along the same straight line path before and after collision. Okay, before and after collision the two bodies will move in the same straight line path, and that is called what? Head-on or one-dimensional collision. Oblique or two-dimensional collision. So what is meant by two-dimensional collision? Colliding bodies do not move along the same straight line path. Okay, colliding bodies do not move along the same straight line path but lie in the same plane before and after collision. One of the example is that while you are playing carom boards, the caroms, how they are moving in the same plane, but they are not moving always in the same straight line. They may be moving in different direction in the same plane. So this is an example for what? Two-dimensional collision. And one more point you have to remember, in all types of collision, what is conserved? Linear momentum is conserved. So I hope it is clear for all types of collision. Okay, thank you all of you.